Alright, so I was looking over what I just recorded and realized I said something really stupid, which is I said I keep on talking about like loading memory into the GPU, and that's not correct because, right, GPU is just a processor. What I really meant to say was VRAM, virtual RAM, right? You want when you're uploading stuff from your I guess you could call what's an abstraction, host and device, right? The host is the CPU side, and then the device is like the GPU side. So I think a lot of times when I was saying CPU and GPU, I meant CPU side and GPU side. You know, like CPU side memory and then GPU side memory. But, you know, I'm not a professional here, so sorry. Okay, so the next step is to get a texture uploaded. And before we upload a texture, we need to create a texture. Right, we gotta reserve that memory on the GPU. I said it again. We have to reserve that memory in VRAM. So to do that, I don't quite know how to do that, but I do remember having a website stored in my notes for reference. So if I can find that really quick. And I have some old code I could probably also reference as well. But I think it would probably be better or easier to just, you know, take a look at trying to figure out how to do that. So let's see. I don't think it's going to be create buffer. I think it's going to be like create texture. So we could search for texture. Textures, and vertex shaders, C textures, and fragment shaders. Let's just search through here a little bit. Sampler 2D. Okay, so this is telling us how to. Okay, create texture, bind texture, and then there's some like format stuff. And I had some notes about how to do that, so I'm going to go over here. And in my notes, I had notes for the format of the texture, because we need boy, this is going to be annoying, because we really do want to use we want to, let's see, once we create this, okay, well, let's get it working first, and then we can figure out how to clean it up later. So I can probably just take this right here, because I know I need it. And, you know, we can do this, we can put this right here. And these are the formats that I know I need to use, because I always use unsigned values for integer textures. I'm always working with integer textures because, right, all of the ways that I do tiles are usually procedural. So these comments are pretty self-explanatory. Some of the stuff has to be changed around a little bit though, because, right, this is for now, we can, what we could do, we can also make a comment slash pixelwidth there. We can bring these over to the comments in case we need to reference them for some reason after we remove this. And then what we can do is we're just going to hard code 512 and 512 for now. And the reason we're hard coding stuff is we just want to, like, get it running, right? We want to get it running, and then we can abstract and refactor things out of here, right, after we have it running. I believe level is like the LOD, or the number of LODs in the texture. For like MIP map levels, I believe that's what this 0 is. Border 0, I'm not sure what border means, like around a texture, but I also think it's like this antiquated thing that people never use. Could be wrong. And then some other things. Okay, so ArrayBufferView. Okay, so this is the actual data. I didn't know it had to be an ArrayBufferView. Like, I know there's some weird stuff, but BufferView, really? Okay, so what we're gonna do here, and really I should, okay, my timer's gone. I'm gonna take this PixU32, and I'm gonna try to find it in some old code that's written really crazy. Like, really crazy? Like, if you thought my code looked crazy here, then, oh boy. Okay, so we're just gonna search for that in some old code that is already doing this, and kind of figure out what that's all about with the ArrayBufferView reference there, because that seems kind of weird to me. I don't see it. Whatever. Let's just click around. Instance of uint32 array. Oh, okay. So what I think an ArrayBufferView is it's like, it's gonna take that byte array and it's gonna interpret the data as a array of uint32 by clustering together the bytes into clusters of 4. Could be wrong. Commit. So this thing would actually make sense. Commit. Let's see. And what I said about crazy, right? Because I have all this stuff, and I honestly can't tell you what all of it means anymore. But the idea was, right? The idea was to have one variable with a very specific meaning. So I have no clue what this means, but you know, if I go search it in my notes, then it has a very specific, exact definition anywhere it shows up in the code. And that's kind of what I was experimenting with, and decided that the Japanese was a little bit of an overkill, but it was interesting to do this way, and I liked how terse I could make code. So putting yeah, I don't know about that. Okay, so I kind of see some stuff. Could also search another code base. So we know that there's text image 2D. We could, right, and we're gonna like, this is one of the things we have when we're creating that texture. So if we look for where it was originally used, we can probably find, let's close this. So I believe sometimes what I do is I use a bash script to concatenate all of my source into one like gigantic source file, which makes it really easy to like control F around in the file for things, and also it makes it a little bit easier to understand how the source code is compiling, because you put it all into one master file before you do anything with it. Okay, so this is the very similar code to what I was using. It has this pixel thing here, also notes and ArrayBufferView. So if we color this pixel thing right here, we can probably find where else it is referenced. Bind texture. Okay, oh, interesting. So active texture, gl.texture0 plus the texture slot value. So, right, so you start at gl texture 0, and then if you want the next texture slot, you add a 1, and if you want texture slot 2, you add 2, and And so texture 0 will be some like for all intents and purposes, we'll call it an arbitrary value. But all of the other texture slots are relative to GL texture 0. So you don't have to use any of the other texture constants. You only need the texture 0. Then you can just add a relative offset to that. So we have that. And then pixels is pixels. Okay, so pixels is pushed in here. And it says uint8 array of texture data. So I don't see anything that says ArrayBufferView unless I'm missing something. Yeah, I don't know why this says ArrayBufferView. Because it, I'm gonna go look up what an ArrayBufferView is. ArrayBufferView JavaScript. So I think that, I think maybe you can. I don't know. ArrayBufferView is a helper type representing any of the following JavaScript type array types. Oh, okay. So this is a ArrayBufferView is a polymorphism kind of thing here. So I am using a uint A array, and that is a type of ArrayBufferView. So it is a derived class of the ArrayBufferView. You could say derived class, or you could say subclass. Subclass always confuses me, like superclass and subclass, and I finally found out why they confuse me. It's because I drew my trees upside down. Like if you draw a tree like it's growing upwards when you draw it on paper, then you'll get confused with like super and sub. But if you start drawing your trees by having the first node at the top of your piece of paper, and then you draw the tree downward, all of a sudden superclass and subclass, it'll actually make sense because the super is now actually on the top, and then the derived classes are actually on the bottom, being the subclasses, right? So sub and derived are the same, and then superclass is the same as base class. Well, not quite the same, but right, they're similar enough to think of them as the same thing as far as I'm concerned. But yeah, getting those synonyms straight in my head was very confusing. And you know, it's not bad for you if you only use the words derived class and base class. You know, you'll have enough tools in your brain to like think about code properly. But then if you talk to other programmers who use slightly different terminology, you need to understand their terminology. So if you're used to using the terms base class and derived class, but then somebody else, instead of using base and derived, they use superclass and subclass, you're going to have a hard time comprehending what they're saying because you're not like used to those terms. But yeah, so anyways, this is definitely a polymorphism thing. So and all this code here is like exactly what I need. And before pushing set alignment, and I'm not sure what the hell or why the hell that's a necessary thing. So we're gonna look up Pixelstore I. I don't really know what that does. But I have it in the code that says I should do it before I push, so I'm going to guess it's important. So Pixelstore I, pname, and then param. Pname, a GL enum specifying which parameter to set. Okay, so it's basically like a constant that identifies something. A lot of times what names in OpenGL mean, they usually mean integers. So they basically mean symbolic name might make more sense. It's just like a name that's assigned to an integer, right? This is a symbolic name, right? Because it evaluates to a number, right? So that's what they mean by name, okay? They don't mean name like a string, and that confused the hell out of me for a very long time. They mean name as in a symbolic name where a number has been assigned some type of human readable phrase, right? So whatever GL unpack alignment, right? GL unpack alignment, it's just a number, right? Technically everything in code is just a number. Even strings are numbers, right? They're just bytes, just ASCII or Unicode. So maybe name shouldn't have confused me as much as it does, because like everything is eventually a number, right? Everything's an abstraction, and everything is really just a number. Okay, so let's see, what is the param? I was just looking at the documentation here. Okay, so we have Pixelstore I, pname and param, a GL int specifying a value to set the pname parameter to. Okay, so I get it. So the way this works is, I guess Pixelstore I is like is probably a family of commands. It's like a family of commands, and then this is like a nailing down a specific command of this family of commands, and then here's the actual parameter to the command. That's not, yeah, OpenGL can do some very weird things. But I'm fairly certain that's how you should interpret this, right? Especially because this is like a constant value. Yeah, so let me look at this documentation a little bit more. Okay. So now we can look at the pixel storage parameters and pack alignment. That's what we're looking at. No, we're looking at unpack alignment. And the description, unpacking of pixel data from memory. Okay, so okay, it's a GL int. Allowed values 1, 2, 4, and 8. A tip I've heard before is if you don't know what the hell you're doing, just like pick one, right? Because the 2, 4, and 8 are, you know, implying that your data is divisible by 2, 4, or 8. And if that is not the case, well, you can always use 1, right? Because everything is divisible by 1, right? So if for some reason your texture is a prime number, you can always use 1. Okay, so we've kind of looked at that, and I have an idea of, so I'm gonna take that, right? I'm trying to save energy here, right? Like, I'm not trying to reinvent the wheel, you know. What is that joke? Coding is just like cutting and pasting from Stack Overflow. In here, that's kind of what I'm doing right now, except I'm kind of like reading some documentation, so I know what the hell I'm doing, right? Like, I'm not like cutting and pasting blindly. I'm looking at some code, looking at what parts I should like cut, right? And then I'm kind of like being like, okay, well, what is that, right? Okay, so texture parameter I. So I'm doing this shorthand, so I'm binding this. So you use the bind GL to keep the this reference, because otherwise these functions, these methods could get like disembodied from their object if you don't bind them, and then they become just procedures that don't have a this argument. So if I want to use this like this, you know, very, very shorthand, right, the TP is text parameter I got to use bind. Otherwise, if I don't bind, it'll be text parameter I, and it'll be that function call, but the function will get called without the this argument, and the code will just do weird things. The code definitely isn't going to work, and it'll just do weird things that can sometimes be hard to hunt down. So JavaScript is this weird thing where it's not quite object-oriented, but it's not quite procedural either. So the this argument is a good example. The this argument in JavaScript is kind of like mostly exposed. It's like the JavaScript argument. JavaScript's this argument it's kind of like partially exposed, right? Like unlike in like C code, if you want to do an object-oriented pattern in C code, you would just always have to pass the object as the first parameter to functions that are acting as member methods. But in JavaScript, this argument is implicitly supplied to a function, and this argument is usually the outer function that wraps the inner function. So that's kind of why you can use functions as classes. So functions and objects, the line between them is like kind of blurry in JavaScript. So scopes, JavaScript has this thing called function scope, and when you call a nested method, this argument for a nested method is the containing function scope of the method. So it's like if an inner function's this is the outer function, or is all like the variables and things in the outer function that is enclosing the inner function, if that makes any sense. Okay, JavaScript is just weird. It does a lot of weird things, and it's good to know about to make sure you don't screw yourself up in JavaScript. Know about function scope versus block scope, or sorry, they don't really have block scope, do they? I think they do have a block scope, but you have to use like the new let keyword for a block scope. So it's usually function scope in JavaScript, so you need to know what function scope is. Variable hoisting is important, and then semicolon injection. Those are like the three things that are really like shoot you in the foot if you don't know about them, because you'll like those problems will evade you even when you're looking at the code in the debugger, right? Because you don't see the injected semicolons in the debugger, and then the debugger just like jumps to weird places because like a statement that's like after a return value, a return call doesn't get executed and you didn't realize it. So anyways, I'm getting off topic.